In this video, we will find multiples of a natural number. A common fraction is written as a over b, or a slash b, where a and b are whole numbers and b cannot equal 0. B does not equal 0. If one unit is divided into 4 parts, the fraction 4 divided by 4 represents the single unit and is an example of a common fraction. The bottom number, or denominator, indicates the number of equal parts that make up one whole unit. The top number, or numerator, represents the number of parts being considered. Here we have a couple of examples. 1/4. There are 4 pieces to this block, and one of the pieces is shaded. That's the only one being considered, so that's 1/4. Here we have 7 pieces to the block, and 3 of them are shaded, so that's 3/7. A fraction shows the relationship between two numbers. If 3 of 500 manufactured parts are defective, then the fraction 3/500ths shows the fraction of the parts that are defective. Fractions also show division. 12 divided by 3 can be written as 12/3 or 12 over 3. Either one is acceptable. Example. Write as a fraction each of these 5 out of 8. Let's start with that. 5 out of 8 would be written as 5/8. Likewise, 3 divided by 10 we can write as 3/10. The unit is the standard amount when writing fractions. 4/4 and 3/3 each represent 1 unit. Fractions that represent less than 1 unit, like 3/4 or 3/7, are called proper fractions. Fractions that represent more than 1 unit, like 7/5, are called improper fractions. The numerator and denominator of a fraction are separated by a horizontal bar or a slash. This bar or slash is called the fraction line or fraction bar, which also serves as a division symbol. When using fractions to describe division, the numerator is always divided by the denominator. The numerator is the dividend, and the denominator is the divisor. Improper fractions can be written as a whole number when the numerator is divisible by the denominator. For example, 10/5 is equal to 2. In an improper fraction, where the numerator is not divisible by the denominator, the fraction can be written as a combination of a whole number and a fractional part. For example, 7/5 is equal to 1 2/5. A mixed number consists of both a whole number and a fraction. The whole number and fraction together are added together. So 1 2/5 is one whole unit and 2/5 of another unit. Fractions indicate division, and multiplication and division are inverse operations. By looking at relationships between multiplication and division, we can find patterns that may help us understand fractions. If we count by 3s, we obtain multiples of 3. Each is the product of 3 and a natural number. 3 equals 3 times 1, 6 equals 3 times 2, 9 equals 3 times 3, and so forth. A multiple of a number is the product of that number and a natural number. To find a multiple of a multiple of a natural number, multiply the number by any other natural number, including itself. For example, show that 2, 4, 6, 8, and 10 are multiples of 2 by writing each as the product of 2 and a natural number. That's not so hard to do. Obviously, 2 is equal to 2 times 1. 4 is equal to 2 times 2. 6 is equal to 2 times 3. 8 is equal to 2 times 4. And 10 is equal to 2 times 5. Natural numbers that are multiples of 2 are even numbers, and natural numbers that are not multiples of 2 are odd numbers. Example, find the first 5 multiples of 16. To do this, we just multiply through by 16. 16 times 1 is 16. 16 times 2 is 32. 16 times 3 is 48. 16 times 4 is 64. And 16 times 5 is 80. We say that a number is divisible by another number if the quotient has no remainder or if the dividend is a multiple of the divisor. It's good to be able to tell if one number is divisible by another by inspection, which means that we can check for divisibility without dividing. Here's a list of tests for divisibility by the first 10 natural numbers. First, every number is divisible by 1. If a number is divisible by 2, the last digit of that number is 2, 4, 6, 8, or 0. If a number is divisible by 3, the sum of the digits is divisible by 3. So for example, if we take a look at the number 15, 1 plus 5 is 6, and so 15 is divisible by 3 because 6 is divisible by 3. To see if a number is divisible by 4, we check to see if the last 2 digits of the number in order form a number divisible by 4. We can tell that 1,212 is divisible by 4 because the last 2 digits, 1, 2, form 12, which is divisible by 4. A number is divisible by 5 if the number ends in 0 or 5. A number is divisible by 6 if the number passes the test for divisibility by 2 and 3. We have no test for divisibility by 7. The last three, a number is divisible by 8 if the last 3 digits in order form a number divisible by 8. A number is divisible by 9 if the sum of the digits is divisible by 9. For example, 18 is equal to 18. We add the numbers 1 and 8, we get 9. 9 is divisible by 9. 18 is divisible by 9. Finally, a number is divisible by 10 if the last digit is 0. So here are some examples for these number tests. We are supposed to determine which of the given numbers are divisible by the given divisor. So our first choice is the numbers 874 or 875, and we want to know which is divisible by 2. It's 874 because it ends in a 4. Now we want to know if 275 or 270 is divisible by 3. Well, if we add up the digits 2 plus 7 plus 5, that's 9 plus 5 is 14, which is not divisible by 3. But 2 plus 7 plus 0 is 9, which is divisible by 3. So 270 is the number we're looking for. 80 or 82, well, 80 ends in a 0, so that's the 1. 804 or 802. Both of them end in a 2, so we need to check to see which of these, both of them end in 2, 4, 6, 8, or 0. So we need to check which one is, when we add together the digits, is divisible by 3. 8 plus 0 plus 4 is 12, but 8 plus 0 plus 2 is 10. So 804 is the number we're looking for here. 3,160 or 3,162. Well, 160 divided by 8 is 20. So 3,160 is the number we're looking for. 477 or 475. We want to see which of these adds up to a multiple, the digits add up to a multiple of 9. 4 plus 7 plus 7, 4 plus 7 is 11, plus 7 is 18, which is divisible by 9. So 477 is the number we want. Finally, we have 182 or 180. Clearly, 180 ends in a 0, So 180 is the number we're looking for.